it says live.
So, one's live,
Now,
Okay, welcome to the Edgerton Explore Center, and let's explore it. Today we are going to talk a little bit about Newton's laws of motion and demonstrate his laws of motion for you today. And first off, we kind of have them broken down here. So Newton's first law is over there on my card. We have an object that's in motion is going to stay in motion. An object at rest stays at rest unless acted upon by an outside force. So we have a couple things that we're going to show you that are going to demonstrate this first law of motion. And to do that, we have Nicole stepping in to help us demonstrate this. So right now we have a sled, and it's sitting on the carpet, and what I need is my object, all right? So Nicole is going to be our object. I'm going to have her sit on the sled, and in order to move my object, there's a couple things that we have to overcome. One is gravity that is pushing down upon the object, Nicole, and the other one is how it moves across the floor, which is friction. So in order to do that, I am going to be the force, all right? I'm going to apply the force on our object here. So let's try this out right now. I'm going to try. I'm not getting any motion there. So the other thing I have to do is I have to be able to apply more force to get my object to move. All right, here we go. Ready? Oh my goodness. All right, so what happened here is my object wanted to stay in place. All right, so remember the law? It said an object in motion stays in motion, but an object at rest stays at rest. So she was at rest. I exhibited the force, and my object wanted to stay back here. So now, we kind of know what's going to happen, right, Nicole? All right, so we're going to do this, and we're going to get you going here. Ready? All right. Now, there goes the other part of the law. Now I got the object in motion. It came to an abrupt stop, but my object still was in motion, and it slid on the sled. So we can kind of talk about that when we're in a car and we're driving. Mom and Dad had to put the brakes on very suddenly. We are the object in the car, and when we come to an abrupt stop, we would be in motion. But there's a thing that saves our lives, and that's our seatbelt. So that's why it's important that we wear our seatbelts when we're in the car, because a motion, we could go flying through the windshield. All right, so that is Newton's first law. Now, we are going to talk about his second law. Newton's second law is a little equation here, and it is F equals m times a. So F meaning force, m is mass, and a is acceleration. So we have a little way to demonstrate this, and we're going to use this, which we're going to say it represents the surface of the moon. All right? And when we do this, we have two objects. Nicole has these two objects here in her hand. Now, one is larger, the other one is smaller, but they're both made out of metal, so they're both smooth. And we're going to drop them from the exact same height at the same time, and we're going to see what happens when they impact in our surface here. Now, a good question here is, are they going to drop and hit the surface at the same time? Or because one is heavier, is it going to go and land before the small one? So as we're kind of looking at that, this is where we're going to do the experiment, and we can see it live right before our eyes. So Nicole, get ready to drop. We're going to give it a countdown. 5, 4, 3, 2, 1. Okay. So, in my opinion, they landed at the same time. Even though one was heavier and bigger, the little one still hit at the same time. Now, the difference that we have here is, if we can kind of look closely, is the amount of impact or force that was applied when it hit into our surface area. So we have a bigger crater, a lot more of the white powder was thrown out than the littler one. So gravity or friction plays a part on when it lands and when it travels. So the bigger one, even though it's heavier, there's more friction applied to it, and the littler one can go faster because it is not as much gravity on it. Then we have way more flour that is thrown out because there is more force impacted from the impact. So if you look at the moon and you see all those craters, there you can see that the moon has been hit with a bunch of meteors. All right, or space objects. All right, so that's Newton's second law. All right, we're going to go now over here to Newton's third law. And Newton's third law is really a fun one, and you might have seen this around. It's called a Newton's cradle. And Newton's third law says, for every action, there is an equal and opposite reaction. Okay? So what is going to happen here is, with Newton's cradle, is John is going to demonstrate moving one of these heavy balls, and whatever happens on one side of our equation here, or the balls, we have 5 of them. So the first ball, he's taking back, and he's going to let it go, and we're going to see what happens to the other side of these balls. Okay, so this is being, whatever happens on this side is going to happen exactly the same on the other side. So the momentum is carried through the balls, and then the energy is expelled here on the other side. All right, so now the fun thing is, let's try it with 2. So we have 2 pulled back, and we're going to see what happens to the other side. All right, here we go. Exactly keeping it equal from one side to the other. So 2 and 2. All right, so now, this is a tricky one, because if we want to pull 3 on one side, we only have 2 on this side, and how is that going to make it equal? There's something that's going to happen that is going to make our equation equal out. So John, let's demonstrate here. Okay, so that middle ball has to decide which side it's going to go. So the energy is transferred through there, and we have it transferred to the other side of the equation. So there we have Newton's third law of motion with, for every action, there is an equal and opposite reaction. Okay, well, is there anything else that we need to discuss with Mr. Newton? I think that kind of hits all 3 of his laws of motion. Thank you for joining us today, and we'll see you again on Friday for another fun little demonstration.